Yeah, can you see my screen now?
Yes, sir.
See the screen? Okay, perfect. Now let's try to address this part. We'll see this part now. So question says clearly that two particles, each of the mass m and the speed v, travel in opposite directions along the parallel line separated by distance t. Show that the angular momentum vector of the two particle system is the same whatever be the point about which the angular momentum is taken out. Okay, so let's draw the diagram for it. Okay, so let me just draw the diagram. Let's say there is a these two are parallel lines. Okay, now so look at this. This is the what he's saying is this is the velocity, this has the velocity v, correct? And this
Yes.
has the velocity opposite direction, right? M. So let's say by any point of charge, so this is the m and velocity is v here. Okay, and here direction is mv, correct? Here also mv. Fine. Now we need to find at any point. So let's say the point and distance they have given to is d, correct? Distance between two parallel lines is d. This distance is how much? D distance. Okay, let's consider any point. Let's consider all the 3 points we'll consider. Okay, first we'll consider the point, let's say here, then we'll consider the point here, then we'll consider the point here. Is it okay? Everywhere consider, or we can take it this point here also. Fine, all the points we'll consider. Let's say first consider the point A, and then point B, then point C, correct? What is the angular momentum at the point A? So at the point A, this, look, the angular momentum is given as L is given as R cross P, correct? No?
Yes, sir.
R is, so here at point A, what is R here? Perpendicular. See, momentum is in this direction. This is, momentum is in this direction. So it passes through the point A. So the perpendicular distance of this direction with the point A is 0. Correct? No? Because it passes through the point A, so there is no perpendicular distance, right? Into mv, correct? Correct. Next part.
Yes.
Now, next part. Now, what is the angular momentum with respect to the first part, right? Angular momentum is r cross p. So here at point A, what is the perpendicular distance? The perpendicular distance is, let's see, this is the direction of this C point. Perpendicular distance from point A is this much, correct? Perpendicular distance. So this is, distance is d, correct? So that's for the second part. Angular momentum is how much? L2 is equal to R cross P, right? So R is nothing but here D into mv, correct? So you got total angular momentum is how much? L1 plus L2 is equal to 0 plus dmv, correct? So you got is how much? dmv, case 1, right? At A, fine. Next, let's consider for the point B, angular momentum at point B. Okay, so let's consider this distance as angular momentum at this point D. So this distance, let's say this perpendicular distance will be how much? Let's assume this is x. Okay, this distance is x, then up above this distance will be d minus x, correct?
Yes.
Above distance will be d minus x, isn't it? This much distance, right? This much will be d minus x, correct? Now let's find angular momentum at point B. Angular momentum at point B. Okay, this will be given as, first we'll consider angular momentum for this part, the bottom one. So here mv into r, R is what? X, perpendicular distance x, so it will become x into mv, correct? Let's say clockwise direction is positive, right? So this is also going in clockwise direction, right? This is rotation from point B. This also will be given as plus, what is the position vector? D minus x. Perpendicular distance is D minus x, right? So D minus x into mv, correct? So it will become xmv plus dmv minus xmv, correct? Still you are getting the dmv, isn't it?
Yes, sir.
So here also you are getting dmv, here also you are getting dmv, correct? No, it is constant. Now at the point C also, if we calculate, it will be the same only. You can do that for also, you know, because this momentum will become, this r cross the angular momentum is 0. This will be same, correct? No. Clear? Any questions? Any doubts?
No, sir.
Okay, let's consider the point, you know, the other than this part. Is it okay? Let's consider the point, this part, last point. Just a minute. Let's consider the last point at point. Let's say this point is D. Okay. Now, how much perpendicular distance? Let's see D point here. So here, this much distance is, let's say, y. Okay. So angular momentum at point D, at D, will be equal to L1 plus L2, correct? Now what is L1? Let's say calculate the angular momentum for this part, okay? This part is going in this direction. Let's say this, at the point B here, this is going in the, it's turning the anti-clockwise direction, isn't it? So this will be taken as, let's say this anti-clockwise will take it as a, clockwise we have taken positive, so the anti-clockwise, let's take it as a negative part. Is it okay? Up to you, you know, whichever we can take it. You know, so let's consider this as a negative. So it becomes a minus y. What is that? mvy, correct? mv. Now what is the angular momentum of this part now? First one at the point C. So basically this creates the clockwise direction. So positive. So this total perpendicular distance will be d plus y.
Yes, sir.
So this will be d plus y into mv. So this will be what? Minus y, we can do here, minus y mv plus dmv plus ymv. So ymv cancelled. So it will be dmv only. Understood, right? So see, all the points we consider, correct? We consider this point also, we consider this point also, we consider this point also, we consider this point also. All the places we got in the angular momentum is dmv, correct?
Yes, sir.
Now do with your understanding. Clear, right? Any questions, any doubts in this part?
No, sir. No doubt.
Clear? Sure, no problem. Just do with the same thing with your understanding. It will be more clear to you.